All right, good evening, good afternoon, good morning. We have people here from all over the world, so good to see you all. Just fantastic, fabulous out there. I'm this Krishna from India and representing IUCE. So this is another one of our really very good webinars from IUCE, IPS, and GEDC. We're really fortunate to have with us a very distinguished scientist from Iran, Tehran, Iran. The speaker is Dr. Hamid Tagirad, has a BSc degree in mechanical engineering from Sharif University of Technology, Tehran, Iran in 1989, MSc in mechanical engineering 1993, and his PhD electrical engineering from 1997, both from McGill University, Montreal, Canada. He's currently University Vice Chancellor for Global Strategies and International Affairs, Professor and Director of Advanced Robotics and Automated Systems, Department of Systems and Control, and in the Faculty of Electrical Engineering at the KN2C University of Technology in Tehran, Iran. Dr. Tagirad is also a senior member of IEEE and on the editorial board of International Journal of Robotics, Theory and Application, and International Journal of Advanced Robotic Systems. With that, I'm going to let him take it over, and welcome, and we look forward to your presentation, Dr. Tagirad.
Thank you very much, Krishna, for your very nice introduction. It is really my pleasure to be among you in this large network to speak about some way of education and training using some artificial intelligence and robotic facilities. As you see, my the title of my talk is Artificial Intelligence and Haptic Technology in Intraocular Surgery Training. Intraocular surgery training is for eye surgery training, in short. Since we have a broad and large number of audience, I try to give the presentation in a very general form to give you the concepts and the ideas that has been developed in my research lab and has been used for eye surgery training. And I hope that if there are some professionals with us, please just feel free anytime to come in within my speech and ask question, or at the end of the session. So what I will be talking is the use of artificial intelligence and the haptic technology to assist surgery training in medical schools. And this is a very sophisticated issue usually, and having robotic technology being assistive could be quite interesting. My talk would be in 4 parts. After a short brief introduction about my research group, I will go to first to give some robotic technology that has been used in the last decade for eye surgery. And also the prototypes that we have been developed in Iran and in ARAS on that issue. And then we'll switch to my main part of the webinar, that is ARRAS Assist, a product that is ARAS Haptic system for eye surgery training. I will give detailed information about that. And then some future prospect of how we can use mixed reality, virtual reality, and AI in surgery training. As a very short introduction, let me introduce ARAS. ARAS is an acronym of our research group, Advanced Robotics and Automation System Research Group. And also it has its own name and meaning in Iran. It's the name of a river in north part of Iran, which is very delightful for Iranian people. So we have used the name both way to have both meaning coming out of it. In our research group, we work on different topics that is illustrated here. We are are mainly focusing on development of new robotic technology, especially the parallel cable robot are being followed by a group of people. Autonomous robotic and autonomous vehicle or driver-free vehicles are some other part of our research, which also very well equipped with AI and other technology in robotics. We have surgical robotic group, which are focused on the medical application of robotics, and mixed reality in eye surgery, which are newly joined because of the application that I'm talking in this webinar, and also some theoretical aspect of and the cornerstone of all this application-based research, which are on dynamical system analysis and control. And as you see, today I can only talk about the surgical robotic group, some advancement of what we have done in our surgical robotics group. As you see, our surgical robotic group, I have a bit of delay. I should take care of that delay in the transition of the slides. Here we are working on two types of surgeries, eye surgeries, and providing robotic tools for that surgeries. The surgical robotic groups aims at developing new robotic-based technology for robot-assisted surgery and surgery training. And we have established ARAS 23 years ago. So Krishna, I couldn't be a teenager. Of course, I'm working in ARAS only for 23 years now, 23 plus years. Let's just introduce some issues and define what we are talking about. What is an eye surgery and what facilities we can use in it. Usually, eye surgery, which is very delicate surgery, is being done by minimally invasive surgery tools. It means that usually the eye, since it is a delicate organ, will be some tools will go inside the eye with very small incision, and then the surgeon will work on the outside of the eye by looking through the eye. We have two types of eye surgeries. The most common, of course, there are a number of different surgeries here, but the most common and more popular, maybe the most popular surgery even in the world is the cataract. The eye will become black, and then you should change the lens with the artificial lens. And this is now becoming very quick and fast, and usually in 15 minutes or in half an hour, with very small processing or injury time, a patient can be treated because it is using minimal invasive surgery. I will show you some videos about that. And also there are some other part of surgeries that are not on the frontal view of the eye, but on the backbone or on the retina, which is more delicate, and there are a number of them. One of the most important one is vitrectomy. And both of them shall be done by small incision through the eyes. I just show you some videos here. This is some part of the cataract surgery that will be, we call it capsule rhexis, actually a very delicate membrane of the eye should be peeled from the eye, and then some other phaco instrument will go inside to the black part of the eye and then it will break that part, and we have the replacement of the lens in the eye. Here you see the first part of this delicate surgery, which is called capsule rexes. It is peeling a membrane in a circular way on top of the eye, and this membrane will be created or remedied by itself actually after the inclusion. Of course, we don't have that much time, and I don't want to show you so much blood and to get away from this talk. But here is the second part of the eye surgery that we call vitrectomy. Here you see that there are some incision made on the eyeball, and then as you see, then some instrument will go inside. We should have light inside, and also we should have some vitrector surgery tool that, as you see, the surgeon will see the inside of the eyeball, and then there are a long procedure of taking off the liquid inside the eye, and then usually we have also, as you see there, some membrane peeling that are being done on a retina. And it is again very delicate, and the eye surgeon need at least 5 to 10 years of training to be able, after they should have fellowship and certain treatment and training to get that. And of course, if you the accuracy of the hand of a surgeon should be about 10 to 100 micron here to avoid any problem on the retina of the patient. Okay, I hope that you get a picture of that. Of course, the delay don't show you the exact. I just want to have a sense of what we are doing. Now, since this part of robotic is very delicate, so we can use robotic technology to assist the surgeons during the operation, and this could be very useful. Of course, it should consider all the ethics here, but we can have some robotics coming on top of the minimal invasive surgery. And since there are the minimal invasive surgeries, the routine way to do the surgeries, this robotic tools could be a handheld robotic facility. As you see, the surgeon just take that handheld device, and that will help to reduce the tremor and also to increase the accuracy of motion. And it is not really doing something, the robotic or this handheld by itself, but it is just assisting the surgeon toward the surgery. We will see some of this component here. This is one part of the surgery, robotic assisted. The other part, at the end of that, it could be done totally autonomous. This is the way that the future of medical system or medical program is conducting. We should consider not in very far years away that this could be done totally by a robotic system if we can transfer the skill of a very skilled surgeon to a robotic system. And we call this fully autonomous. So of course, this is still too early right now. The middle stage is really happening with Da Vinci robot, and other similar robot, which are teleoperated. A surgeon will move some hand, as you see, some haptic devices or some handles here, and then look into the microscope away from the patient, and then the robotic system will do the operation. And this by this means we have the human in the loop, and we have the artificial intelligence of a human in the loop. And Da Vinci and other type of robotic system are developed for doing that, and there are many robotic operation being done. And here I show you some products very quickly. The first one has been developed in Johns Hopkins University. It's called Steady Hand Robot. This is commercially available, basically, and as you see, this will help to reduce the tremor of the surgery hand. The second one is also developed in 2011. This is called this is called Precise Robot, a very interesting name like ARAS. A Precise Robot is basically a very precise robot, and it is using also some sort of parallel robot manipulator. And as you see, it shows in this figure how accurate it can be doing the operation compared to the very small tremor of a skilled surgeon hand. And the third one is also developed in KU Leuven in 2017. This is basically a handheld device, but it can be also used for autonomy. As you see, the surgeon can use this robot for doing the same procedure. And all of these robots that I showed you, or these devices, these assistive devices, are working on for vitrectomy on the retina part of the eye. And this is the developed robot that we have been using and developed in 2016. 5 years ago, we have used this special spherical type of robot, like this spherical eye. It is very, very effective in terms of the space that it will take, and it is very accurate and can provide us the means for autonomous surgery. At that time, we worked with a number of very famous and very delicate surgeons and professors in Iran who have been doing that for years, and we try to make some clinical experiment with that robot. Of course, not just in Iran, but everywhere in the world, as I know from my colleagues in Canada and also in the United States. This is a very, very difficult task. Both the technology should be advanced enough and have the standard, the required standard, but also there is the mental issue that all people think if the robot come into the surgery room, then the surgeon should go out. And this provide a very large resistance, although our group of ophthalmologists were very keen to do that, but it was not very welcomed to bring the robot into the surgery room. But provide us the decision that we have. It provides us with some very, very advanced and better technology, not for robotic operation, directly operation, which is quite advanced, to use the robotic or the haptic device for training, for surgery training. And this provides us with the last 5 years of research that we have done on ARRAS Assist. Again, ARRAS Assist is an acronym of ARAS Haptic system for eye surgery training, as you see, and ARAS is a very, very famous figure in Iran from Shahnameh Ferdowsi, and that's also an Iranian name we put on this device to have it quite seen in terms of research and technology that has been advanced. So the very, very quick introduction, why we need some sort of assistance in the surgery training, and how the surgery training is really being operated right now in medical schools. You can see that right now, I will show you that the surgery training is very difficult. The trainee should first see the motion of the hand of the expert trainer. And also use some simulators to do some practice. But before doing some real operation on the patient, he or she never gets well experienced. And the common technique of surgery training is sometimes referred now to see one, do one, and teach one. And this is the way I mentioned. And there are quite possible that within this training period, some complication being appeared during the surgery. And this is usually when we call it for cataract surgery, there is posterior capsule rupture. There is a complication that is a problem that a very small or a very easy cataract surgery can return into a very difficult surgery if the PCR will happen. And also for vitrectomy, if there are some retina puncture, if the tool will hit the retina, then there is some problem with the nerves here, and then the visual impairment. And this will happen not very seldom, but for expert surgeon, it happens 3%. And this is the global view. But for Iranian surgeons, usually this is about 1 to 1.5% complication during the surgery. But for novice surgeon, if there is the trainee is doing that, this can come up to 11%. And this means that from each 10 patient that is being the surgery is operating on his or her eye, from each 10 patient, one of them comes into this problem, if the unwanted problem. And if we can reduce that, it would be very important. And the issue is that not only on the side of the patient, also on the side of the supervisors and the people who are supervising the trainers during the surgery. They have a lot of mental pressure during the surgery training. And actually what we have provide here is like the driving assistance for learning driving. You know, there is a trainer on the other side, and he or she can stop the trainee if there is an accident being happening. But of course, this is very delicate, and the operation is much more in depth. So we have two haptic consoles designed and implemented in ARAS specifically for vitrectomy application. And we have two, the trainee and the trainer are cooperating with each other in three different regimes that I will show you. And then we have the training being well done during this set. So we have a collaborating training or a multi-user robotic system that we are very familiar in other industrial approaches, not in surgery, but here in surgery, this is a very could be a very good and common sense opportunity. And as you see, this training could be in 3 stages. At the first stage, as you see, the professional or the trainer will do the training, will do this operation and the surgery, and by this, the tool is kept by this haptic device, by ARRAS Assist, and the motion of the hand motion of the surgeon will be replicated to another stage or another console that the trainee is getting that and getting more experience how the expert trainee is working. After getting a bit of work on this, on real patient, and you see that this operation is done on real patient, on real eye, and there is no simulators there. There is directly everything being done on real patient as it is done. After the stage we could go to the stage 2 that now the trainee will do this training, And now the expert is, the supervisor is watching it carefully. And if there is some problem, of course, you should give freedom to the trainer to do some problems. Not he or she is not always the perfect, but you can avoid getting puncture or retina puncture or PCR if the case is going to be somehow dangerous. Then the trainee have the right, and I will show you how we can, and the control system that can overrule the trainee. And of course, after some training, then the trainee would be expert enough and do the surgery without use of any assistive surgery training here. And this idea was flourishing for our surgeons and ophthalmologists, and we tried to develop some haptic devices. We don't call it robot system. There are some robots. It's very similar to the previous robot that we use, but there are somehow some sensing devices and some haptic devices in terms of giving force feedback and also force motion. They are all equipped with DC motors, very, very delicate motors. And this is the ARRAS Assist one. There is some parallelogram mechanism to use that very accurate design, and also some capstan or cable-driven system to have very accurate motion coming out of that. We did some experiments, some first experiment, and then we come up with the second version of ARRAS Assist. We call it ARRAS Assist 2, which is the more advanced and with a large workspace. And as you see, the inclination to have the vitrectomy workspace quite well, and having some more dexterity, and then we try to use that in practical system. You can see the experiment here first at the lab scale. As you see, these two devices are electronically or wirely connected to each other, and the trainee and trainer motion can be replicated in two sides. And as you see here, the trainee is giving the motion, and the trainer can every time that it seems that it is not good, can interrupt. And there is also a pedal. The pedal is the critical point. If there is some dangerous incident happening, can use the pedal and then get all the authority here. And the authority adjustment here, the control technique that has been used, is very well sophisticated and quite important. You can see here some part of the experiment that we have done with ARRAS Assist 1. This is our colleague, Dr. Mohammadi, the ophthalmologist that is working with us. At a very early stage, as you see in our lab, he just worked with the robot and found out that give us some feedback on how to change it regarding the displacement and the workspace that we have. Then we have the second robot. Again, this is in our lab, and as you see, we have some international collaborator from Canada with us to develop the control strategies here. And then after doing these steps of experiments in the lab, we moved to some skill lab tests. We moved to the most significant and important eye hospital in Iran, which is called Farabi, in Tehran Medical University. And this hospital is dedicated for eye surgeries, basically. As you see, there are some other colleagues of us that are now using the two system all together, and to see how these are working in the dry lab. Of course, it is not on the patient yet, and the system is open. Everything is open to do the correction that is required. And then finally, we also did some experiment with our very dear colleague, Dr. Lashei, one of prominent professor in Iran in eye surgery vitrectomy training, and he also examined the device and give us feedback. And then finally, we did some clinical tests, some real tests on not on a real eye, on an eye bank, basically on a donated eye for the research and development, as you see. And as you see here now, the vitrector and everything is doing the same operation that was is going to be happening on a real patient eye has been done in here. Now, it seems that everything is finished. Anything missing? Still, there are some other issues to be talked. I think I would like to have about 5 more minutes, if you don't want to give some future prospect of that. Of course,
no problem. No problem.
Okay.
Go ahead.
Okay, so the missing part, I shall explain it to you. Of course, if you get acquainted with the surgery, you will find it quite easily, but the missing part is something that we can come up with some mixed reality and artificial intelligence to fulfill this gap. And this is, you know, when we have two consoles, we have two trainer and trainee working on the same eye, can't both see the operation scene by itself. We have two different consoles here. And as you see, the first console is operating on the real eye, but the second console, as you see here, maybe there are some, of course, some operating room monitors that the trainer should look up and see what is going on. And this is not the right way, you know. Usually they should look down on the microscope. The second way is to use, you know, a double-headed microscope. They have also some problem, and many problem, not some one. They are very close to each other. The trainer and trainee should, you know, be in contact here. And in COVID situation, this is impossible right now to get the distance that is required. And also in terms of the image reflection, when you have two microscope, then usually this microscope reflect the vision that you can see the right angle, the right position there. We come with a very another smart way to do that, and using VR headset. Why just being so close to each other? Since we have a wired system, we can just provide the scene for the second console, or for the trainee or the trainer, through virtual reality. And this is quite amazing. And since we are a very good developer in artificial intelligence, we like to do that. And this is the way we are working now. The second console, this is Ali Reza, one of my former PhD student, the head of the MR team right now, can put a very similar Oculus VR that has been used for games and different other approaches, but to see what is really happening in the first console, and also have the device, have the hand on the ARRAS Assist to give the force feedback. But this means now you can consider that, of course, this is under development yet, and I show you some early result, but you can see that the patient real eye data can be obtained from a complete set of eye scans that is usually done, and the trainer can perform the surgery with a haptic console, not a real surgery, with a haptic console on the video captures that the real eye and surgery tool motion has been done already before. We can put that video capture on a simulator, on a model with AI, with artificial intelligence technology, to put a real surgery training on simulators. And then this, as you see, the trainee can watch first several times and move, give the motion of the hand on what the trainee is doing on the first stage in a 3D and immersive environment, quite completely like what he or she is doing on a real surgery. Of course, this gives only the simulation part. It can go a step further, more further. The trainee can now be guided. Now the trainee can do this, not only watching the videos and moving the hand, but we can have it guideline how to move the hand in, for example, the capsule rhexis, how to move your hand to get that case, all in artificial intelligence and in a virtual space. And not only that, we can have some skill assessment now. We can perform that several times on the real simulators. And then if it is quite skilled, then we can go to the last part and the main product that now both surgeons are now doing that. Just the haptic console, the second haptic console is empowered by some virtual reality. And this is not virtual reality because we have also haptic device. We have also some tools coming in. We call it a mixed reality. We have a mixture of real tools with a virtual environment vision for the second capsule. And this is very, very advanced, and it needs at least I guess about 3 to 5 years research. We are in the first year of that research right now. As you see, we have the haptic device. For developing the simulators, we need a framework. We use the SOFA framework and Unity Unreal game engines that usually used to provide us with the real 3D immersive system, and also a headset that could be a simple Oculus headset toward each other. And then you can see that for example, for cataract, you need to have a 3D model. You should provide the meshes and the topology there. You should have collision. You should have adhesion. You should have many physical properties being implemented in here, and also the force feedback that we require in the haptic device. And then here I show you the early stage of what we have done already. We have again the model of the eye implemented in the SOFA framework with different captures for both cataract and also for vitrectomy. Here you can see the eye, the initial eye, without embedding any real picture or real images of the eye, but having the meshes and mechanical properties that we require in here, and to have the collision computation and so forth and so on. Here you can see how the tool can be come inside the picture and have some physical property like elastic property or cutting property through the eye surgery that we are using. And finally, we can have also the phantom haptic device, another haptic device, to put some forces on the real system in here. As you see in this movie, we have some motion in the haptic, and then on the simulator you can feel the collision or the forces back and forth, what we require to do that. And also this has been done for vitrectomy, where two groups of people working, one on cataract and the other on vitrectomy. And as you see here, we have the membrane, suction or peeling being presented here. You can see a more advanced scene here. As times evolves, the simulations and the simulators are becoming better. Now we can embed the eye, the lightning through the eyes, and become very, very similar scene as the trainee is watching in the real vitrectomy. And finally, the future prospect, of course, is to do some clinical investigation, to do the patenting and commercialization that we are among that, and also to develop these VR tools for further, and AI technology for further development. I hope that it was interesting for you to come across another interdisciplinary area between medical and the engineering part, and how a robotic tool can help. And of course, I should thank the sponsor of this long research team, two of our university in Alberta and Queen's University. We have some professors from Canada also helping us with, also Tehran University of Medical Science, and some supporting agencies. And these are the pictures of the people who do the real job, and I am the one who should just talk about it. Thank you very much for your attention and the time you gave me.
Very, very fascinating. Very, very fascinating, Hamid. So delighted to hear such a futuristic presentation, but actually very, very practical implications. I was actually just looking up on my iPhone this definition of haptic technology, and it says it refers to any technology that can create an experience of touch by applying force, vibrations, or motions to the user, and by virtual computer simulations. Amazing. So you've taken us to the future with all the work that you're doing. While we're waiting for folks to come up with questions and comments, I was just curious. This obviously is a combination of many years of amazing technology from some amazing people with outstanding backgrounds, not just from Iran, but you seem to have partners all over the world. How do you put this together? I mean, the funding required and getting all these right people together. What's the secret to your
Yeah, this is the other thing that I shall do, not only talking and presenting, providing the fun. And of course, what I can say, if I start with maybe go through with this last chapter, the most important asset that we have in Iran is talented and trusted students. This is the most significant part. I really enjoy when I'm not teaching them, I'm working with them and learning from them, not only teaching them, of course. At the beginning stage of their studies, maybe we are some teaching, but at the real time, as you see here, for example, you see a number of all of these are students at one particular year. Some of them are PhD students, some of them are. And we have the opportunity to have this good student. And of course, this good student goes all over the world. In India, there are many Iranian students. In United States, in Europe, and other ways. Of course, some of them remain with us, and we can have. But the other thing that is very important, we have funded the first stage of the development by our grants. The first robotic system, we had 3 versions of that robotic system. But after having a prototype, then the ARRAS Assist was basically funded by some medical or interdisciplinary medical agents, both in Iran, and also some part of it is funded by some NSERC Canadian agency to our partners there. Of course, we look for more collaboration and avenues to further. Right now, we are going to have 3 different set of haptic device being designed and implemented and go to 3 different universities or 3 different hospitals to be really clinically examined and get in working.
Truly interdisciplinary, absolutely. And is 2C a government institution, or is it private? How does it work?
No, it is governmental institution. We are among the top 5 technical university in Iran, and that's why usually we have some formal grants and internal issues to do that. But of course, this long way of keeping everybody all together, I can say that this is done just by passion. The people are really passionate about the work they are
We can
doing.
see that in you. We can see that showing up in you. Document.
Thank you.
So Jennifer tapped one of our participants saying, what a wonderful and informative presentation. Look forward to more comments, folks. Come in, guys, about 60 or 70 of you here. Allah, I'm going to put you on the spot. You can unmute yourself, Allah, and jump in. Allah is our current president of IFIS here, Allah Ashmavi. Come in, Allah.
Thank you, Krishna, and thank you, Dr. Hamid, for just an amazing presentation. I really don't have questions. I'm just in awe of the information that was presented. You know, very interesting, because this is really where we see engineering at its best. You know, serving humanity, serving society, and as part of our peace engineering initiative in IFIS and so on, trying to address the sustainable development goals of the UN SDGs. You know, this is spot on. This kind of work is really amazing and really addresses these challenges that we'd like to tackle. So I only have just comments, is that we're very excited at IFIS. They have someone from Iran for the first time to
Yes.
present a webinar. So
Yes.
this is really exciting and just amazing, really amazing, the work that we see, and we see how much engineering goes into surgery, goes into medicine, which we don't think about quite a lot. But it's very impressive. The work is very impressive. Thank you so much.
Thank you for your comment.
A comment from Gajanan says, I think you had some statistics about cataract surgery being 1 in 1,000. Is that what was that about, the frequency?
Yes, it is a bit more than that, less than 1,000. And the number of surgeries in the world is quite extensive, very much.
Yeah. What about the frequency of vitrectomy?
No, vitrectomy is vitrectomy is the wider range. You know, you have very small problems, from very small problem to the general vitrectomy. Vitrectomy is about 100 times less than cataract. About 100 times less.
Right. Well, we have people are so amazed that they don't really have any comments for us right now. I'm just waiting to see anybody else. Hans, you have some comments to make right now?
I do. Thank you very much, Krishna. Dr. Hamid, very inspiring. And what I was thinking, particularly Allah's comments, how the medical profession working together with engineering and the creativity, the political and psychological sensitivity to bring those different disciplines together, because many times the disciplines in the academic world have their own islands. And what I'm just learning from you in this awesome presentation, this is a whole different way of working, very creative. Just one comment. The other comment, again, also following up what Allah just said, this is important. We deeply value the engagement of the Iranian Society of Engineering Education in the IFIS global community. And this is an important first steps. And what I saw, particularly passion in your presentation at the end of the question, is the engagement of your students. And you were saying, I'm learning from my students. It's not just the one way they had doctor, professor, giving knowledge to professors, to the students, but vice versa, per se. So, and this is a deep commitment of our IFIS community, or the IUCE community, the creative work that Krishna is leading in India, for example. And I want to set the sort of the tone and so forth. We are planning, again, every year, an annual conference this year in November in Madrid, Spain, and an important and very successful engaging dimension of our global work, Hamid, is the participation of students. And I want to up with you, your university. Also, I have, and you can help me also in connection with the University of Tehran, for example. Let's find ways to engage, of course, the faculty and certainly the deans and leaders such as yourself, but the students increasingly engaged in a creative way. I'm just very proud and very, very happy of that. So I just wanted to mention that to you, and listen, thank you again, and let's very much stay in touch, and be safe. You and all of our wonderful participants today during this critical time in our lives. Krishna.
One of your students from Iran, Mehnaz Mahmoudi, says thank you for the excellent presentation. It is very useful. As an Iranian mechanical engineer student, I'm very proud to attend this webinar. Thank you, Mehnaz, for joining us. And then Gajanan says it shows engineers without borders working within the same group in medicine in a great way. We need to deepen. We need to drop the political boundaries for humanity. I think that's a very important statement there.
Yes,
Great.
yes.
If I have just 1 minute to comment on the comment of Hans, I just want to say 2 sentences. First, my first experience with working with medical doctors, where I was in my PhD student, when I was a PhD student at McGill, there was something to be sold by engineers, and I happened to come to the picture, and the most difficult part is to get the same language. Of course, we both speak in English, but we had different languages, and it took me maybe 2 or 3 months to just understand as Krishna, read about haptic, to find what is going on there. But after you have this kind of bilingual, you have understand your languages, your ideas, then engineering can help a lot in various different areas of medical school. And the second thing I would like to say, it is, this is the case I usually graduate one of my students. This is really true, when they come as a student that want to work with our group, they should be passionate. They should be, well motivated to spend all their time on the research. And when they can graduate, there is one very simple question and very simple evaluation. At that time, he or she should be more expert than me in that specific area. And if it is like that, then it is time for him or her graduation. So it is really true that you really learn from each other, both when you are working, especially in interdisciplinary area. And I am very happy that I have the opportunity to have so many good colleagues, and today I have added some new colleagues to my network, and I hope that will help me to collaborate more with the global community.
Good. Aliki has a comment for you. He says, Dr. Hamid, can you please share with our audience any information you have on webinars that you and your team may be offering to your community? We can share the link with our attendees here. So in future, if you have any webinars around these areas, they're virtual, you just send it to Aliki and we will share.
Of course. I just, if you just go through my home page, I have put the home page on here. We have a active webinar link. The address is ARAS KNTU. This is this webinar today webinar. This should be familiar with you. And after the webinar, we usually put also the recorded media here for future, for other. This is my 8th webinar in here, and you can see different webinars going on here with different people. As you see, I don't know if you look, you have my still screen or not. Just go through my website, and it is quite simple. ARAS. You remember ARAS, very eminent river in Iran. ARAS.kntu.ac. Then you search through that, you can find quite. Of course, I will share And not
Yes,
only
and
my webinars, but the network of my network webinar with Aliki
yeah,
in
just send
future.
Aliki and she'll distribute it among the IFIS community. Great. Thank you so much. Amazing. Okay, once again, big round of applause to you and your team, as you said, your
Thank you very
students,
much.
who made it
Peace
all
be with
Thank
you.
possible.
you.
Everybody
Thank you,
be happy, be
Krishna.
safe, and stay healthy. Okay, bye-bye.
Bye.
Bye-bye,
Okay.
everybody. Thank you.
Bye.
Bye-bye.